Hi, good day. In our past discussion, we already learned the basics of reduction and oxidation. We learned that reduction is a gain of electron, while oxidation is a loss of electron. Also, we learned how to balance the equations in reduction and oxidation. Now, if you are not yet familiar with those topics, might as well watch my video about Introduction to Electrochemistry. And the link for that video is on the description box below. Now, most of the times, reduction and oxidation do not happen separately, but instead, they happen simultaneously in this type of reaction known as redox reaction. Redox is actually a portmanteau of the words reduction and oxidation. Red for reduction and ox for oxidation. Here, the electrons lost by an element during the oxidation can be gained by another element during the reduction. To give you an example, let's have here a zinc with no charge at all. When this zinc reacts with copper ion with a charge of positive 2, the zinc will release 2 electrons, and these 2 electrons will be captured by the copper ion. This will turn the zinc to have a charge of positive 2 and the copper ion to have no charge at all. Therefore, the one that underwent reduction is the copper ion, while the one that underwent oxidation is the zinc. If we are going to put it into an equation, for reduction, we have here copper with a charge of positive 2, and it actually gained 2 electrons. Again, these 2 electrons came from the zinc, and it actually turned the copper ion to become copper with no charge at all. For the oxidation, again, the one that is actually oxidized is the zinc, and it actually turned the zinc to become zinc with a charge of positive 2. Now, the 2 electrons lost during the oxidation are actually written at the right side of our equation in oxidation, and the 2 electrons gained during the reduction are actually written at the left side of our equation in reduction. Now, take note that the one that causes the zinc to undergo oxidation is the copper ion, while the one that causes the copper ion to undergo reduction is the zinc. Therefore, our oxidizing agent is the copper ion, while our reducing agent is the zinc. Or in short, oxidizing agent is a reactant that underwent reduction, while reducing agent is a reactant that underwent oxidation. Now, if we are going to combine all the reactants and all the products in these equations to form our redox equation, then we will have here copper with a charge of positive 2 plus 2 electrons plus zinc will yield to copper with no charge at all plus zinc with a charge of positive 2 plus 2 electrons. Now, because both sides of this equation have 2 electrons, then we can actually cancel those 2 electrons. And we will have here the final balanced redox equation of copper with a charge of positive 2 plus zinc with no charge at all will yield to copper with no charge at all plus zinc with a charge of positive 2. Now, this process that we did to balance our redox equation is what we know as balancing through half reaction. Now, let's have another example of balancing through half reaction. For this one, let's have manganese with a charge of positive 7 plus chloride ion with a charge of negative 1 will yield to manganese with no charge at all plus chlorine gas with no charge at all. Now, the very first thing that we should do here is to balance the elements. Here, we have 1 manganese and here we have 1 manganese, and therefore, our manganese atoms here are already balanced. But here, we have 1 chlorine atom and here we have 2 chlorine atoms. Therefore, our chlorine atoms here are not yet balanced. Now, to balance this, all we have to do is to add 2 stoichiometric coefficient here to balance our chlorine atoms, and we will have here manganese with a charge of positive 7 plus 2 chloride ion with a charge of negative 1 will yield to manganese with no charge at all plus chlorine gas with no charge at all. Now, the second thing that we should do is to determine which one is reduced and which one is oxidized. For this reaction, the one that is actually reduced or that underwent reduction is the manganese with a charge of positive 7. And the one that underwent oxidation or is oxidized is the chloride ion with a charge of -1. Okay? Now, for manganese with a charge of +7, it turned into manganese with no charge at all. So that's from +7 to 0. So that's from +7 to here. That's 1, 2, 3, 4, 5, 6, 7. 7 steps towards the left side of our number line. And again, a movement towards the left side of our number line is considered reduction. On the other hand, our chloride ion here, which has actually originally -1 as its charge, will now have a charge of -2. Why? Because we actually multiplied our stoichiometric coefficient here. Our stoichiometric coefficient here is 2. 2 times -1 is -2. So from -2, it turned into chlorine gas with no charge at all. From -2, it turned into 0. So that's 1, 2. 2 steps towards the right side of our number line. And again, a movement towards the right side of our number line is considered oxidation, and therefore this one underwent oxidation. Now, the next thing that we are going to do is to add electrons gained during the reduction or lost during the oxidation. Now again, in reduction, electrons are on the left side of our equation, and in oxidation, electrons are on the right side of our equation. Now again here, the one that underwent reduction is the manganese with a charge of +7, and the one that underwent oxidation is the chloride ion with a charge of -1. Now for reduction, our manganese with a charge of +7 turned into manganese with no charge at all. So that's from +7 to 0. From +7 to 0. Okay? And the question is, how many electrons did it gain? So for that one, again, from +7, okay, to 0, that's 1, 2, 3, 4, 5, 6, 7. It actually gained 7 electrons. Now again, where are we going to put those 7 electrons? In reduction, electrons are on the left side of our equation, and therefore we will have here manganese with a charge of +7 plus 7 electrons, again on the left side of our equation, will yield to manganese with no charge at all. Now for oxidation, let's have here again the chloride ion with a charge of -1, and it turned into chlorine gas with no charge at all. Now the question is, how many electrons are lost during this reaction? Okay, so the very first thing that we're going to do here is to multiply our stoichiometric coefficient in our charge here. So that's 2 times -1 is equal to -2. So we are going to start in -2. So from -2, it turned into chlorine gas with no charge at all. So that's 0. So from -2 to 0, that's 1, 2. 2 steps to the right side of our number line, and therefore it actually lost 2 electrons. Now, where are we going to put those 2 electrons? Again, in oxidation, electrons are always on the right side of our equation, and therefore we are going to put those 2 electrons on the right side of our equation. Okay, and we will have here the equation 2 chloride ion with charge of -1, okay, will yield to chlorine gas plus 2 electrons. Now, the next thing that we are going to do is to find the least common multiple of the electrons in reduction and in oxidation. Now again, in reduction, we have here 7 electrons, and in oxidation, we have here 2 electrons. Now, what is the least common multiple of 7 and 2? That is 14. Therefore, we should multiply our equation in reduction to a number that will turn these 7 electrons into 14, and we should also multiply our equation in oxidation that will turn these 2 electrons into 14. And what are those numbers? For reduction, we have here 2, and for oxidation, we have here 7. So for reduction, that's 2 times the manganese with a charge of +7. We have here 2 manganese with a charge of +7. 2 times 7 electrons is 14 electrons. Okay? And 2 times our manganese with no charge at all is equal to 2 manganese. Okay? For our oxidation, we have here 7 times 2 chloride ion with a charge of -1, and that is 14 chloride ion with a charge of -1. For chlorine gas with no charge at all, that's 7 times 1, 7 chlorine gas. And for our electrons here, 2 electrons times 7 is actually equal to 14 electrons. Now, as we can see here, 14 electrons, or the 14 electrons in reduction, can be found on the left side of our equation, and the other 14 electrons in oxidation can be found at the right side of our equation. Therefore, we can actually cancel these 14 electrons. Okay, and we're going to combine all the reactants that we have here and all the products that we have here, and we will have the final balanced redox equation of 2 manganese with a charge of positive 7 plus 14 chloride ion with a charge of negative 1 will yield to 2 manganese with no charge at all plus a 7 chlorine gas with no charge at all. This is now our balanced redox equation. So those are the important concepts that you need to know in order to balance a redox reaction through half reaction. Thank you for listening and good day.